Alrighty, and we are going to start a new section here called IP networking. Basically, computers use a whole lot of IP addressing in order to communicate between different computers, in order to figure out if a computer is on the same network as itself, or if it's on a remote network, or if it's even a valid address to communicate with. And it does all this using IP, Internet Protocol Addressing. In order to start off talking about IP addressing, we need to talk about binary addressing. Binary is how IP works. Everything in a computer is based off of binary, so to understand the basics of how it's all built, we need to understand how binary works. Now, the great thing about binary, even though it sounds really, really scary, is that it is, in fact, a simple numbering system. Now, when I say numbering system, I mean, well, it's just like our numbering systems that we are used to today, which is base 10. So right now we are using decimal, or what's referred to as base 10 numbering system. Basically, most people have 10 fingers and 10 toes, and therefore it was very logical for us to create a numbering system that took count of those 10 digits. So it's composed of 10 different numbers, 0 through 9. And the great thing is everything in decimal, everything in base 10 uses 0 through 9. There's no numbers outside of that we use. Till you get into that weird math with imaginary numbers. Now, because it's base 10, everything is based off of base 10. We have ones. Now, if I take 1 and I multiply it by 10, I then have tens. If I take 10 and multiply it by 10, I then have hundreds. By 10, I then have thousands. And so on and so on. Base 10. Everything is built off of that. Well, binary is essentially the same thing, except instead of base 10, it is base 2. We use 2 numbers, 0 through 1, instead of 10 numbers, 0 through 9. Computers use base 10 because, well, they don't really have fingers. Computers simply recognize an on and an off, not necessarily variations of that on and off. Not very well, anyway. So, the binary, or base 10, binary, by the way, I always remember it as base 2 because a bicycle has 2 tires. Bicycle, binary, 2. There we go. So, just as we were talking about with how base 10, everything multiplies by 10. So we start off with ones, we then multiply by 10 to get the tens, the hundreds, the thousands, the tens of thousands, and so on. Binary multiplies everything by 2. So again, we start off with ones. We then go to 2s. We then go to 4s, 8s, and so on. 16s, 32s, 64s, 128s, 256s, 512s, and so on and so on. You'll recognize those numbers more and more as you go through the class. But yeah, everything in base 10 is based off of multiples of 10. Everything in base 2, or binary, is based off of multiples of 2s. So it's just a number system. Just like decimal, we're just not used to it. And that's why we're here to learn. So there's lots of other numbering systems out there. There is actually what's referred to as a hexadecimal numbering system, which, if you remember your geometry class in high school, you have the term hex, which refers to 6. 6 sides of an object, such as a stop sign. Hopefully that's a stop sign is 6 sides, not in 8. But so 6, and then we have decimal, which is 10. So 6 plus 10 equals 16. So hexadecimal is actually base 16. Yeah. And then there's lots of other numbering systems out there. For instance, the Mayans. Apparently the Mayans didn't wear shoes as much. Maybe. The Mayan number system actually uses a base 20. So they counted both their fingers and their toes, and it still worked. Everything worked perfectly fine. It's still, once you understand the process, is very easy to follow through and repeat with somebody else. It just uses 20 numbers instead of 10. Yeah. Okay, so let's look to see exactly how this works. So I'm going to open up an Excel spreadsheet here. Now this may look familiar. If you were way back in the elementary days, your teacher told you that the number, let's say 145. The number 145 is not simply the number 145. The number 145 is actually composed of 5 ones. Along with 5 ones, it also has 4 tens, 100, and 0 thousands. I'm actually going to leave the thousands blank there just so it's easier for us to read there. So 145 is 1 100, 4 tens, 5 ones. Okay, I remember doing that. And then as we were learning about how to add these numbers together, the teacher then said, well, let's add 3. Let's add 3 to those numbers. So I'm not adding any thousands. I'm not adding any hundreds. I'm not adding any tens. I'm only adding 3 ones. So then I just simply combine these to get these two together. 5 plus 3, well, that's 8. 4 plus 0, that's 4. 1 plus 0 is 1. And then 0 plus 0 is 0, so I'll leave that one blank. So now 145 plus 3 is 148. Well, that makes perfect sense. Let's do that one more time just to see what happens. Let's add another 3. So again, I'm not adding any thousands, not adding any hundreds or any tens. I'm adding 3 ones. 8 plus 3 is 11. Oh, wait a minute. We've got a problem here. Decimal only goes from 0 through 9. And here, I have an 11. Oh no, the world's coming to an end. Well, as I'm sure we all remember our elementary classes, what happens when we have more than 0 through 9? Well, we take this extra 1 here, and we carry it over to the tens slot. Yeah, okay, I'm starting to remember here. So 8 plus 3 is not 11. 8 plus 3 is 1. Oops. And carry the 1. So now I have 4 plus 1 here, which is 5. 1 plus 0, which is 1. 0 plus 0, which is 0. And so my number is now 151. So that's the key point to remember there, is when the ones column got full, when 8 plus 3 equals 11, I then have to carry over the 1 to the tens column. And the same thing would happen if in the tens column, if my tens column used more than 0 through 9, I would carry over to the hundreds column. Or if the hundreds column used more than those numbers, carry over to the thousands or the tens of thousands or hundreds of thousands, simply carrying over those columns. And so I end up with essentially my numbering scheme of 0 through 9. And then, so I start off with 0, I add 1, add 1, add 1, and I get all the way down to 9. And then when I add 1 more, I have 0, and I carry over to the next column. So now I have 2 columns. I have both ones and tens. And I continue on all the way down to 99, and then I carry over to the hundreds, and so on and so on. Now, the reason why I'm going through this very basic information is because this same idea carries over to binary. So here we have a binary, the same format, just talking about binary. Let's give it a number, just pull one off the top of my head, 101. Now the binary number 101 is not the decimal number 101, and that will hopefully make more sense here shortly. But the same process we went through with decimal, with base 10, carries over with the 101. So here I've gone ahead and filled out, I have 1s, 2s, 4, 8, 16s. I could continue this on, 32s, 64s, and so on. For this demonstration, this will be more than enough. So how many 1s do I have in my number 101? I have 1. How many 2s do I have? Well, I have 0. And then how many 4s do I have? I have 1. So you can see I have exactly the same 101 right here with 101 right there. Just simply placing them out in the separate columns the same way we did with base 10 of the 1s, the 10s, the 100s, and so on. Here it's just 1s, 2s, 4s, 8s, 16s, and so on. Well, so now that I've gone ahead and broken this out, let's go ahead and try adding a number here. So if I want to add the number 1 to 101, remember I only have 2 digits, so I have to go with either 0s or 1s. I'm not adding any 16s, any 8s, any 4s, any 2s. I'm simply adding a 1. All right, so 1 plus 1 is, 1 plus 1 is 2. Except now I have the same problem I had before. If in base 10 I only had 0 through 9, and if I exceeded 9, I had to carry over a digit. Here in binary, I only have 0 through 1, and if I exceed 1, I have to carry over a digit. So this 2 right here is the binary equivalent of 10. You can't have the numbers, you can't have 10 1s. What you can have is a 10 and no 1s. So here I have a 2. Well, I can't have 2 1s. What I can have is a 2 and 0 1s. Yeah, so what this does is my 1s column now becomes a 0, and I carry the 2s. So now my number is 110. Let's try that again. Let's add another 1 to it. So this column is, this row is exactly the same as before since I'm just adding 1. 1 plus 0. Well, that's easy. That's 1. All right, now we have 1 plus 1. Oh, it's the same issue we just had before, except this time instead of being in the 1s column, which we had right here, we now have the same problem here in the 2s column. So I can't write 2 down here. I have to write 0 and carry the 1. All right, so let's go ahead and do that. We write the 0 down here. We carry the 1 over to the 4s. Oh, now I have exactly the same problem. 1 plus 1 is 2. I don't have 2s in binary. So I'll carry the 1 over. So that's a 0. Carry the 1 over. 0 plus 1 is 1. So my new number is now 1001. And so it's exactly the same process as in decimal of the carrying of the 1s. Just looks a whole lot different because it's using binary instead of decimal. So let's look at this a little bit further. Actually, let's open up a new sheet here. In decimal, we have our number 0, 1, 2. Actually, let me zoom this through here. If you've never done this in Excel, it makes life a whole lot easier. So here I have numbers 0 through 12 in decimal. Let's do the same thing in binary. I don't think I can do the zooming, so I'll have to do it myself. In binary, we start off with 0, and then we start off with 1. Now again, when we get to 2, we've run out of slots for the 1s, so we have to start doing the 2s. So instead of having one simple column of numbers of our 1s slot, we now have to carry over to the next one, which is 10. 10 plus 1, 11. 11 plus 1, 100. 101, 110, 111, 1000. 1001, 1010, 1011, 1100, and so on and so on. So it's the exact same process when you look at the very basics of how it worked, of separating out the 1s and the 10s and the 100s and simply carrying over these numbers as was necessary. Same thing happens in binary, except it's 1s and 2s and 4s and 8s. Multiples of 2 and carrying over of 1s as necessary, until we end up with a numbering scheme that follows decimal almost exactly. In fact, it is so almost exactly. Let's continue this on. That we can actually go all the way down to, oh, not 16. Well, let's see. 1101, 1110, 1111. And then we get all the way up to 16, 100, 00. There we go. Now I talked briefly about hexadecimal. And hexadecimal actually follows along very, very closely with this 0 through 16. In fact, so closely, I'm just going to copy and paste what's these first 10 digits off of decimal. Once we get to hexadecimal beyond the numbers 9, well, if you try to think about what numbers may exist beyond 9, you probably can't think of any. So they actually went to letters. So once they go from 0 through 9, they then go through A, B, C, D, E, and F. And then finally we get to the very end and we simply carry over to this next column. In this case, the hexadecimal, we have 16 1s. And then we go into the 16s column, which would be 10. So there you go, 3 different numbering systems. They all work exactly the same. I always go back to the way how decimal works, of carrying over from one column or one number slot to the next in order to determine the carrying over of the digits as you exceed the maximum number in that numbering system. Again, for decimal, that's 10. For binary, that's 2. And then for hexadecimal, that's 16. And if we really wanted to go even further, there is the base 20, and I'm sure we could find trinary and even a whole lot more. But there you go. That is the introduction to IP networking. Everything you may have never wanted to know about how binary works. And this is the foundation that we will use as we talk about IP networking, of how the IP addressing itself works in order to communicate with other machines on the network.